right, 4.4, investigating the nature of roots. So we're going to look at the roots of a quadratic and what important information can we get from them. The other day we talked about discriminant. Discriminant, remember, was the part found underneath the root sign in the quadratic formula. So the part that was found underneath the root sign in the quadratic formula is b squared minus 4ac. Now this discriminant helps us define whether a parabola will touch the x-axis once, twice, or possibly not at all. So let's look at an example of two parabolas here. Notice that these two parabolas will never ever touch the x-axis. And because of that, the discriminant will actually tell us that it won't touch the x-axis. That is, when the discriminant b squared minus 4ac is actually less than 0. Because if the value is negative, it means that it will not touch it. Because, folks, it's impossible to find the square root of a negative number, a real value, that is. Let's look at it. So, if the discriminant is negative, there are no real roots. Next, what happens when the parabola touches it just once? So the vertex touches the parabola. Vertex touches the x-axis. The vertex of the parabola touches the x-axis only at that point and nowhere else. What happens then? Well, that is, the discriminant, b squared minus 4ac, is actually equal to 0. That is, in this case, when we're looking here, this parabola will touch it exactly at one point. That is, the discriminant will actually equal 0 because there's only one possible root, and that root is actually the axis of symmetry, or the x value of the vertex. Okay, next, the last one. Looking at these two parabolas, you might think, well, they don't really touch the x-axis, but remember, these arrows mean they go beyond. So both of these arrows here in this parabola are extending and going beyond and touching the x-axis. The same can be said for this parabola. As I extend these arrows, they will touch the x-axis 2 times. Okay, even another one. Let's say this one. Again, it touches the parabola at 2 points. So what does that mean for the discriminant? Well, the discriminant, b squared minus 4ac, will actually be greater than 0. That's right. It will mean that the discriminant is actually a positive number. And because it's positive, we can say that there are 2 real roots, 2 solutions to the problem. So, let's look at some examples that apply to this. All right, so without drawing the graph, state whether the quadratic function intersects the x-axis at 1 point, 2 points, or not at all. So let's look at the first example, just so that you understand how to do this. Sorry, folks, that was a little bit too much there. We're only going to do the first part here. So for part A, we have this equation, f of x equals 5x squared plus 3x minus 7, and we need to determine whether it has 1 root, no roots, or 2 roots. Well, we need to identify the a value, which is 5, your b value, which is 3, and your c value, which is negative 7. And what we're going to do is just plug in that information into the discriminant. Not the whole quadratic formula, but the discriminant. So discriminant is b squared minus 4ac. Plug in the numbers. b is 3 squared minus 4 times a, which is 5, times c, which is negative 7. We plug it in, and we get 9 plus 140 is equal to 149. Well, 149, folks, is actually greater than 0. It's a positive number. And because it's a positive number, we know, therefore, that the quadratic function intersects at 2 points. Okay. Now, let's do B. So we're going to erase all this and do B. A is 4. B is negative 1, C is positive 3, and the discriminant is b squared minus 4ac. Plug it in. So we get negative 1 squared minus 4 times 4 times 3. We plug it in, we get 1 minus 48, and that will give us negative 47. Well, negative 47 means that that number is less than 0. And because that number is less than 0, folks, that means that there are no real solutions. So this quadratic function doesn't touch the x-axis whatsoever. Okay, so we've done example 1. Let's move on to example 2. Example 2, and it's not example 3, folks. We're looking at example 2. What we want to do is state whether the quadratic function intersects the x-axis at 1 point, note 2 points, or not at all. And what we're going to do is not sketch an accurate graph, but an approximation, an idea what this graph might look like. For example, we want a graph where the vertex is located. The vertex is going to be 5 and 4.5. So the vertex is 5 and 4.5. That means it's located somewhere in the first quadrant. So up here somewhere. We don't know where exactly, but we know it's somewhere here. We also know that this graph opens up. So let's draw it opening up. Well, that should tell you that, oh, there are no x-intercept. It doesn't touch the x-axis whatsoever. So the quadratic function will not touch the x-axis. And that's because the vertex is above the x-axis and the graph opens up. Let's look at the next one. What about this one? Well, first identify the vertex, folks. So the vertex is negative 2, 3.5. And when we locate it in terms of a quadrant, it's going to be found in this quadrant, somewhere over here. And we know that this particular parabola opens, that's right, it opens down. So we draw it opening downwards. How many times will that parabola touch the x-axis? Well, I hope you're thinking, okay, that one's got to hit it twice. And it does, folks. The quadratic function will touch the x-axis twice because the vertex is above the x-axis and the graph opens down. Okay, let's look at another example. One more, folks. All right, what we're going to do here is we're going to solve this problem. All right, in this case, for what values of k does the equation kx minus 10 equals 5x squared have one real solution? So what we need to do is find the value of k to make this true. What does it mean to have one real solution? Well, I hope you're thinking the discriminant. So, before we do that, we need to put this equation, this one over here, in such a way that we can use the values. So 0 equals, and I'm moving everything this time over to the right-hand side, so you get 5x squared minus kx plus 10. Another way that you could have done is moved everything to the left-hand side. So it would be negative 5x squared plus kx minus 10. Either way, folks, I guarantee we'll get the same answer. Okay, so we're going to use one of these methods and not the other. So, to understand this, we know that this parabola, okay, to have one solution means that the vertex has to touch the x-axis. It also means that since there's one real solution, the discriminant has to equal 0. That's right, the discriminant will equal 0 if we have one real solution. All right, and how are we going to do this? Well, b squared minus 4ac is equal to 0. We set that equal to 0 because there's one solution. So the discriminant equals 0, and you identify the a, the b, and the c. So the a is 5, the b is negative k, and the c is 10. So we plug it into the equation. b is negative k squared minus 4 times 5 times 10 equals 0. Now we need to solve for k. So negative k squared is going to turn into positive k squared minus 200 equals 0. We move the minus 200 to the other side, it becomes plus 200, and now we solve for k. K will equal plus or minus the square root of 200. So this k value is the k value that will give us one real root. So what does the equation actually look like? Well, it looks like negative 200. So what am I doing here is I'm taking the k value and I'm plus and minus. So here we have, looking up here in the equation that we had earlier, 1 second folks, up here we had kx minus 10 equals 5x squared. So we're literally plugging in k. We're doing the negative, so negative kx minus 10 equals 5x. And the other one is going to be positive root 200x minus 10x. 10 is equal to 5x squared. Okay, well, let's see if there's a... Let's hope you can understand how to do this problem. You should probably try a few more. When we look at this, don't forget that when you plug it back in, you have to plug in the exact value and not the decimal value. All right, folks, that's the end of the video. Have a numerical day.